Hello everyone. Today I will show you how to use your machine learning process in your for coding point of view. So let's start. Machine learning process to solve any kind of problem in real life problem using neural networks constitute of 5 basic steps. For instance, when you want to perform some object detection, face recognition, or some masking, or something voice detection, character recognition, everything requires 5 basic steps that you should follow in order to get your in order to modulate or evaluate your efficiency, like your code, how much it will work, how efficient is it, how much is its accuracy, and all of this. So first step is you have all the data may be in raw form. So first you need to collect all the data. Acquisition. For data acquisition, you have all your data, and actually there are two parts. We have our code or algorithm. On the other side. So for our data that is used to perform, like for example, if you want to recognize voice of some person, so in your data all the voices will be enlisted, and then you will run it on that particular piece of code, and then you will evaluate your efficiency, your accuracy, that how much your algorithm is workable and how much you can you can say that your algorithm is efficient. So first step is to gather your all the data in raw form, and then second step is data cleaning. So in the second step you need to transform something in that particular set of data. For example, you have 10,000 pictures. All pictures must be in the same environment conditions. For example, if I have some pictures of a particular class, like some students pictures, every student's picture must be in the same dimension, like passport size or maybe some other dimensions in width and height, and also their background again always matters. So every piece of data, every single chunk of data must be taken in a particular environment condition, or maybe some rules that define, like for example, if you are classifying the if you are classifying the animals like dog, cat, in that particular problem you need to detect their particular part. Like for example, if this is the face, then you can extract eyes or maybe nose and place them, all of them, in separate directory. So that all process constitute in data cleaning. Maybe there are some filters you apply on the picture, so every picture must be in same matrix position, and also in same dimension, and maybe some like it also depend on some algorithms. Some algorithms may work in every environment condition, like sometime pictures algorithm that detect some picture can work, like if algorithm is very useful and very effective, then it can work on the on different pictures the same. But if you are like, for example, if you are collecting voice of 5%, so 5% maybe there is some background noise, so you must apply some filter to remove background voice and to synchronize everything that constitute, like that will not affect the accuracy of algorithm. Because sometimes if you are taking the data for the background voice, then it also matters while you speaks, so it may encounter some error. And then after data cleaning, you need to divide your data into test set and train set. Normally what rule follow, 30% of data will be on the training side and testing side, and 70% you separate, like divide your data, the whole data, into two subsets, like one is test set, one is training set. The purpose of dividing this test is you will train your model, you will apply your algorithm on the training set, but we separate 30% of the data, normally 30%, maybe it varies. You separate 30% of data that never been seen by the machine. Like for example, you will see that the human can easily recognize that I have seen this picture before. Is the same like the machine. If data will not be seen by machine before, so in that case we will get the fresh result. And sometimes we'll use this test set using finding the accuracy, uh, and it will assure that our algorithm is also working on the training set, like training set that is being working, and also for all the data that computer haven't ever seen. So after dividing this, you'll first train model. Training your model is is just like fitting your model on training dataset, and you can adjust the model parameters in this particular process, that you must train your model on the particular training set. Like for example, if you are training it for the first time, maybe your accuracy is not so good, like while computer knows that this algorithm is designed for particular type of problem, like detecting, maybe recognition, maybe some other simulation you want to do. And so while training your model set, you get the better accuracy. And after you train your model, you will evaluate